All right, so for 6.4, we're going to take the concept of Riemann sums, and we're going to translate it into calculus. So what we want to look at is what's called a definite integral. And what that means is I'm going to have limits of integration. I'm going to have limits of integration. So we're going to have a starting point and an ending point. Okay, so for example, if I ask you to integrate 4 dx, and then we're going to introduce these little numbers on the top and the bottom of our integral. So this is called a definite integral because these are called the limits of integration. Okay, so here's the method that we use. I go ahead and integrate. So what's the integral of 4 dx? Remember, 4 is a constant multiple. So I could write this as 4 from 3 to 10 of x to the 0 dx. So then my integral will be x to the first over 1. So the integral of 4 dx is 4x. Okay. Now, remember that when you integrate, the integral symbol goes away, and it always has before. So I forgot my plus c. Sorry. All right, so I've got 4x plus c. That is the answer. But this time we have a definite integral. In other words, we've got boundaries to deal with. So I'm going to introduce hard brackets, and those hard bracket means integration is done. Now we're going to evaluate. So the top limit of integration is 10. The bottom limit of integration is 3. Okay. So all I do is evaluate. Remember, these are in terms of x's. So always evaluate top minus bottom. So I'm going to evaluate with a 10 minus evaluate with a 3, combine like terms, and I'm done. Okay, so this first one turns into 4 times 10 plus c minus 4 times 3 plus c. Okay, so I get a 4 times 10 is 40 plus c. And then I get a 12 plus c, but remember this negative is going to change all the signs. So instead of a positive 12, I'm going to have a negative 12. Instead of a positive c, I'm going to have a negative c. So what happens to your c's? Your c's will disappear every time on a definite integral. They'll always reduce out. So being lazy math people, we're just not going to bother writing them from now on. Just remember that they're there, but they cancel out. Okay? So what do I get now? I get 40 minus 12. Well, what's 40 minus 12? 40 minus 12 is 28. So what does this mean? What does the graph of y equals 4 look like? The graph of y equals 4 looks like a horizontal line that slices through the y-axis at 4. And I'm interested in finding the area under that curve only between 3 and 10. So what shape is this? This is a rectangle. So how wide is your rectangle? It's 7. How tall is your rectangle? It's 4. 7 times 4 is 28. Okay, so we got 28 a while ago using calculus. Well, we also could have done geometry. Now, life is not always going to be nice straight polygons and all that kind of good stuff. So that's why we have to have calculus for the rest of it. So our method for this is we're going to be setting up definite integrals, and then we evaluate top to bottom with subtraction in between. Okay, top to bottom with subtraction in between. So let's look at number 2. We have f of x equals 1/6x, and it's negative, plus 1. And I'm integrating between 1 and 6. And we're also using the fundamental theorem of calculus. Okay, so the fundamental theorem of calculus simply says that I can use definite integrals to find area under the curve. Okay, so what is my method? I am going to integrate from 1 to 6. My integrand is a negative 1/6x plus 1 dx. And then how do I integrate? I can go term by term. So the integral of x is x squared over 2. So this is going to turn into negative 1/12 x squared. Okay, x squared over 2, so 6 times 2 is 12. And then what's the integral of 1? The integral of 1 is just x. And remember, your plus c is there. It's just in my way, so I'm not going to bother writing it. So I'm going to evaluate from 1 to 6. So evaluate top number first minus evaluate bottom number. So top number is a 6. So I get negative 1/12. 6 squared is 36 plus 6 minus, and now we're going to go with a 1. So negative 1/12 times 1 squared is 1, which is negative 1/12, and then plus 1. So I shoved a 1 here and a 1 here. So now what do I have? Negative 1/12 of 36 is a negative 3. So negative 3 plus 6. This is going to be a plus 1/12. And that's going to be a minus 1. So what do I get for an answer? Negative 3 and 6 is 3. Minus 1 is 2. And 2 and 1/12 is going to turn into 25 twelfths. 25 twelfths is your answer. Okay, and you always want to do it in improper fractions. If you try and do 2 and 1/12, it's going to kick it out as wrong. Okay, so I get 25 twelfths. Let's try again. And it also says to use geometry to verify your results. Well, we're going to get the same one, so we're not doing geometry. All right, so we have my function is 2x plus 8. My limits of integration are from negative 1 to 5. So I'm just going to go term by term. Okay, so the integral of 2x is going to be 2x squared over 2. So your 2's reduce out. The integral of 8 is going to be 8x. And I'm going to take that from negative 1 to 5. Okay, so shoving a 5. 5 squared is 25. Plus 8 times 5 is 40. Minus, shoving a negative 1. Negative 1 squared is 1. Minus 8, because 8 times negative 1. Okay. So now what do I get? 25 and 40 is 65. Minus 1 minus 8 is negative 7. So that makes a plus 7. So I get 72. Okay. 72 square units. Last piece of paper. All right. So I've got 8x minus 6. So the integral of 8x minus 6 dx, my limits of integration are going to be from 4 to 11. Okay, so they're just giving you the function, and then they're telling you what interval to use. So I'm going ahead and smooshing it all together. Okay, so what's the integral of 8x? It'll be 8x squared over 2, which is 4x squared. What's the integral of 6? It's 6x. Where am I integrating from in 2? From 11 to 4, or from 4 to 11, sorry. And always do top first minus bottom. So top is going to be 11. So 4 times 121 minus 66 minus 4 times 4 squared is 16 minus 24. Okay, so I get 121 times 4 is going to be 484 minus 66 minus 64 plus 24. I have no idea what that is. Okay, so that's going to give me 484 minus 66 minus 64 plus 24 gives me 378. Okay, so I have 378 square units. All right, so let's try parabola. I have f of x equals x squared plus 5, and the x squared is negative. And I'm going over the interval from negative 1 to 2. So that means I have the integral from negative 1 to 2 of negative x squared plus 5 dx. So what's the integral of negative x squared? It is negative x to the third over 3. What's the integral of 5? It's 5x. And I'm going to take that from a negative 1 to a 2. So if I evaluate at 2, 2 to the third is 8. So I get negative 8 thirds plus 5 times 2 is 10 minus Negative 1 cubed is negative 1. Change its sign to a positive 1 third. And then 5 times negative 1 is negative 5. Okay, so what do I have? I've got negative 8 thirds minus 1 third is negative 9 thirds, which is negative 3. I got a plus 10 and a plus 5. So plus 10 plus 5 gives me 15 minus 3 is 12. Okay, so I'm going to pause. I got to find more paper. I have returned. So let's do a 5x. So I'm going to do the integral from 0 to 5 of 5x minus x squared dx. So when I integrate 5x, I get 5x squared over 2 minus the integral of x squared is negative x to the third over 3. I'm going to take that from 0 to 5. Remember, evaluate from top to bottom. So if I evaluate at 5, I get 5 times 25 is 125 squared minus 5 to the third is 125 cubed. Okay. Minus, well, when I shove in a 0, that zero's out and that zero's out. Okay, so that last part is kind of easy to handle. When I get a common denominator, I'm going to get 125 halves minus 125 over 3, math, fraction, and I get 125 over 6. Okay, 125 over 6. All right, so let's do something more exciting. We have the integral of 1 over x dx, and I'm evaluating from 1 to 7. Okay, so I'm evaluating from 1 to 7. So how do I do this? Because remember, if you've got a fraction, the very first place I always go is the derivative of the bottom in the top. If it is, then the integral is the natural log of the bottom. So what's the derivative of x? It's 1 dx. Okay, so this integral becomes the natural log of x plus c. But remember, your c's fall off. So I'm going to evaluate at 7 first. So I get the natural log of 7 minus evaluate at 1. Okay, well, the natural log of 1 is 0. Okay, the natural log of 1 is 0, so that zero's out, and I'm left with just the natural log of 7. Okay, let's try another one. We have the integral from 1 to 9 of 2 times the square root of x dx, which I'm going to promptly rewrite as 2 times x to the 1/2 dx. Okay. So remember, this is an x to the first, but you're taking a square root. Okay, so how do I integrate 2x to the 1/2? It's going to be 2x to the 3/2 over 3/2, which means times 2/3. Flip and multiply. So I get 4/3 x to the 3/2, and I'm taking that from 1 to 9. So if I evaluate at 9, remember that over 2 means square root. So if I evaluate at 9, the square root of 9 is 3, so I did the 2. 3 raised to the 3rd power is 27. So I get 4 times 27 thirds minus, well, 1 to any power is just 1. So I get 4 thirds. So this is going to reduce to, what did that just reduce to? To 36 minus 4 thirds. And then getting a common denominator, because I don't feel like it, is going to be math, enter, enter, and I get 104 thirds. Okay, so 104 over 3. There you go. And I'm going to do one more. Okay, actually, I'm not going to do one more. That's a good spot to stop, and so I'll finish this section up on the next video.